Section 5.2 is on integration with natural logarithms. We learned in 5.1 that the derivative of ln of x is equal to 1 over x. So the inverse of that would be the integral of 1 over x dx is equal to ln of x. Technically, you do need absolute values here around the x's so that the domains match up. Here, x is allowed to be anything, but if we just had ln of x, natural log of a negative number does not exist. So we do include the absolute values there. So integral of 1 over x dx is equal to ln of the absolute value of x plus c. This is the property that we will be using here in 5.2. Example 1 asks us to evaluate the integral of x over x squared plus 1 dx. We are going to start by making u equal to x squared plus 1. Our du then would be 2x dx. We need 2x dx, so we multiply by 2, and 1/2 to cancel out the 2. 2x dx, there's du. I've got x squared plus 1 on the bottom, which is u. And I've got the 1/2 out front. Integral of 1 over u is ln of the absolute value of u. And we substitute back in for u. 1/2 ln of x squared plus 1 plus c. You could have the absolute values on here, but x squared plus 1, if I square a number and then add 1, I'm always getting a positive number anyway. So it's actually redundant to have the absolute values. It's not wrong if you include them. Example 2 is the same problem, but we were integrating the reciprocal this time. Last time it was x over x squared plus 1. This time we were integrating x squared plus 1 over x. Notice if we tried to do it the same way we did the last one, if we made u equal to x squared plus 1, du is 2x dx. I don't have x here, I have 1 over x. I have x to the negative first. So that cannot be part of this du. So I cannot do it the same way I did the previous one. Instead, we are going to split it up. We're going to divide everything by x. So x squared divided by x is x plus 1 divided by x. And now we can integrate. The integral of x is 1/2 x squared. The integral of 1 over x is ln of the absolute value of x. Example 3, the integral of 1 over the square root of 3x plus 1 dx. We are going to make u equal to 3x plus 1. So our du is 3 dx times 3 times 1/3. And we get down to here. 3 dx, there's du. And I will see a lot of students see 1 over a variable, so they'll do this, which is incorrect. 1/3 bringing the 1/3 down, even with the absolute values, it's incorrect. The only rule we had here was 1 over x, or 1 over u, is natural log. 1 over square root of u does not have a natural log. We've actually done lots of problems like this before. we want to rewrite it as u to the negative third, or I'm sorry, negative 1/2. And now we can use the power rule. So if it's anything other than just 1 over x or 1 over u, we're going to wind up using the power rule. Add 1 to the exponent, gives me positive 1/2 times 1 over 1/2. So I get 2/3 u to the 1/2. 1/2 power same as square root, and I substitute it back in for u. Notice if it is 1 over u, if we tried to use the power rule, we said that power rule works for all exponents except -1, because if I add 1 to -1, and have 1 to the 0 times 1 over 0, which is no good. So the power rule does not work when u is -1. We wind up with a natural log instead. Example 4. Looks like a mess. The integral from 1 to e of 1 plus ln of x all squared divided by x dx. As it's written, I think pretty clearly we cannot integrate that. We don't know how to integrate using any of the properties we've done. When that's the case, we usually want to try to use substitute. Not a lot of options on what we can make u. Let's make u equal to this so that I have u squared. So 1 plus ln of x. My du then would be 1 over x dx. Derivative of natural log is 1 over x. This x is on the bottom, so that is 1 over x dx. There's du, and this is going to be u squared. So we have rewritten it in terms of u. Don't forget to change your bounds. Plug in 1 for x, natural log of 1. So you're thinking e, the base of the logarithm, is e to what power is 1? Natural log of 1 is 0, so I have 1 plus 0. Plugging e in for x, we have 1 plus ln of e. E to what power is e? E to the first is e, so this is 1 plus 1 is 2. So now everything, including our bounds, have been rewritten in terms of u. We just treat this as the original problem. Integrate from 1 to 2. Plug in the top one. Plug in the bottom one. And we get 7 over 3. Example 5 of 6, one more after this one. Integral of 2x over the quantity 1 minus 3x squared dx. Try to think of something we can make u, in this case 1 minus 3x squared. So my du is negative 6x dx. I need to make this a negative 6x. I can do that by multiplying by negative 3, and negative 1/3. Negative 6x dx. There's du. So negative 1/3 times the integral. That's du. That's u squared. Integral of 1 over u squared is not a natural logarithm. We need to rewrite it as u to the negative second. Again, it's only if it's 1 over x or 1 over u. Add 1 to the exponent. Divide by negative 1. And our answer is 1 over 3u, which is 1 minus 3x squared plus c. If we were missing this 2 right here, if that was not there, this was not here, now that's when we integrate, we would have a natural log in that case. Last problem, example 6, asks us to integrate tangent x dx. We know the derivative of tangent x is secant squared x. What is the integral of tangent x dx? Let's start by rewriting it in terms of sine and cosine. Tangent x is sine x over cosine x. And we're going to u substitute. Let's make u equal to cosine x. So my du is equal to negative sine x dx. The derivative of cosine x is negative sine. So I multiply by negative 1 to get my negative sine. I also divide by negative 1. There's du, negative sine x dx. So I have negative the integral of 1 over u du. This time we do have a natural log. Integral of 1 over u du is ln of the absolute value of u, and we substitute back in. The opposite of the natural log of the absolute value of cosine x plus c. Those are the notes for section 5.2. That's all we got.